Yeah, I hope you enjoy the explicit title. So let me just briefly translate. Well, we are going to have a very quick talk about how we can plug remote resources to Kubernetes through interLink. That is the name of the tool that I'm presenting. So I'm from INFN, as I mentioned before, so from the Institute for Nuclear Physics in Italy. And I'm a technologist. That is another name for saying that I'm a physicist that is not doing physics anymore. I'm rather playing with cloud-native tools and help my colleagues to do physics analysis pretty quick. So we did already have a presentation longer than this on the tool itself last year in Paris. So I leave the link here for more thorough presentation of all the details. But what we are going to focus here is the new shiny features that are going to break a bit of limitation that we had before. The project itself, born under a European project that aims to create digital twins engine, so a common framework for the many frameworks that are out there for creating digital twins, so digital replication of the reality. And those frameworks should leverage for every task GPUs or specialized hardware. And the challenge here is making frameworks that may create digital twins capable of speaking to any backend that is available, being a supercomputer running SLURM or a special VM, very seamless with respect to the user perspective, and also from the Kubernetes administrator perspective. So it's a big challenge, and we are taking it pretty serious. So bridging our Kubernetes cluster to anything, what I mean by that. So suppose you have your pipeline, machine learning or pipeline or data analysis pipeline, whatever. Usually, nowadays, it's talking in some way to a Kubernetes cluster. So it's talking Kubernetes API language. The idea is it's not original of interLink. Already, Virtual Kubelet is a thing since several years. It's to plug an interface to the Kubernetes cluster to translate the request from the user into something that is custom. Custom like submitting a SLURM job on a supercomputer. And in fact, what we are targeting first is the most limited use case, right? We have the most constraint in our EuroHPC supercomputers. So this is the reason for which we started with this challenge first. Although we are well aware that the HPCs, the supercomputers, are not the only way to get access to powerful hardware. So we designed, since the beginning, the solution to be adaptable and pluggable to much more. So beefy VMs, legacy, if you wish, or normal ways to do high throughput computing in physics, and also, why not, another Kubernetes cluster dedicated to managing GPUs. In general, whatever is capable of running containers. The final aim, the final scenario that we keep in mind during all the development is, OK, I own both my Kubernetes cluster and my resources that I manage in some other use cases that is running SLURM. And this is one use case. The other one is, OK, I have multiple Kubernetes clusters, multi-tenant or whatever, many users that are running their own Kubernetes cluster. I want to expose kind of an edge service of my supercomputer in order to exploit this kind of resources and keep control of which Kubernetes cluster are connecting to this SLURM cluster. So in other words, we have a single tenant scenario and a multi-tenant scenario in mind. All right, then another piece of the puzzle is how we can design something like that. We are basically drawing a middleware for extending Kubernetes. We leverage Virtual Kubelet, as I mentioned before. And we included a particular type of provider that is capable of accepting different kind of plugins, we call it. So a plugin is basically a simple REST API server with an open API spec that if you respect that, you're in. You're basically for free all the automation, all the machinery that expose your resources, your SLURM batch system, as a normal virtual node on your cluster. So a normal node on the cluster. We have a demo on that, so we'll talk better than how I can explain it. In a nutshell, on the blue side, there is your Kubernetes cluster that is running a Virtual Kubelet process. And this Virtual Kubelet process is instrumented to talk to an external entity through an authentication that, in this case, in the supported case, is OpenID Connect standard. So you have your identity provider, you expose a service on your edge service. This communication between your Kubernetes cluster and your remote counterpart is managed through this identity provider. So you trust this connection. Now you are free to talk to the plugin part that the administrator can set up, since it's very simple web server. And now the magic happens. So you translate all the pod specific into a SLURM job, for instance. So you have now, if I had to put my adapter, I'd put it there. So you have an adapter for your remote resources. What it means in practice. So you have a lot of frameworks that are talking to Kubernetes. And then you want to exploit a VM with a lot of GPUs, maybe on the cloud. Or you want to go back to your big computing system and leverage them through HTC components. Or, this is something that we are exploring, we want to attach a system, maybe based on SLURM or something else, that is capable of exploiting quantum computing. And then we go back to the first use case, to our aim, exploring EuroHPC centers. And yeah, it's working, and we will see it in practice right now. So the demo is not going to show just how this works, because we already presented this last time, but it's including a new feature. Right now, we had two main limitations. The first one, we didn't share the in-cluster network within the pods, so we cannot expose something that is running inside a supercomputer. And on the other hand, we have a limited amount of volumes that are supported in this scenario. Well, for the first one, we have something new. We have implemented, let me block here. I'm going to share from my screen, it's better. I'm going to show you how this looks in practice, how this overlay network is working. So we are going to launch, maybe, yes, a Ray cluster for distributed training. And on this cluster, Kubernetes cluster, where you see there are two virtual kubelets. And so let me go back a second. OK, these are the virtual nodes that we are going to use. There is one Vega that is a Slovenian EuroHPC, and the first one is a Leonardo one. And you see they are looking just like normal node on the Kubernetes cluster. Then we go and set up the Ray cluster using the Helm chart, default Helm chart, plain Helm chart. So you see where are we heading. OK, we go ahead. And we put just few annotation. The trick is there. In the annotation on the pod, you can specify all the SLURM activity that you want to include, pre-execution and whatever. And you also specify, OK, give me a pod VPN attached to my main cluster. So you go ahead, you specify a set of worker nodes, and you submit. And you submit your Ray cluster installation. It starts, create a bunch of pods. Here in this test should be kind of 10 or 9. And voila. So now, how this looks into practice, you see the IPs of the pod are essentially the one inside the cluster. And if we look inside the supercomputer, we log in, we clear a bit the shell, and there are jobs running like that. This is not the end. You can now go ahead and see, OK, I want the logs from this pod. And I have it directly from my cluster. So I'm totally unaware that all this stuff is running on a supercomputer. I'm on my cloud environment. I can work just like that. There are some caveats, of course, that I'm going to talk to the most interested of you on a coffee or later this week. So yeah, now we start the job, and you see there are no tricks. It's working just like it would work on your own Kubernetes cluster. You remove stuff, and yeah, that's good. So I hope you are a bit more interested in this kind of technology. Well, different people are looking into it, not only from the scientific part, so from INFN and from other European partners, but there are also other experiments that are looking for Argo workflows. Actually, is working also with Argo workflows. We tested it in the ELISA interferometer. We are clearly pointing to integration with Kubeflow that at this point should be possible. And there are enterprises that look, OK, I have a container as a service solution. Why should I implement my Kubernetes API level abstraction where I can use this? And we have a couple of them looking, and you can find also someone here during the week to talk to. Last news, we have just joined the Cloud Native sandbox, so we are contributing to the sandbox. Just a remark to close. The code base is very simple. It's a very thin layer to be included, so it's perfect for getting started for contribution and get on board. So don't hesitate. Let's grab a coffee later in this week. And yeah, thank you.